Alright, welcome to the 1.6 classified polygons for geometry. In geometry, a figure that lies on the plane is called a plane figure. A polygon is a closed plane figure with the following properties. It is formed by three or more line segments called sides, and each side intersects exactly two sides, one at each endpoint. Each endpoint on the side is called a vertex, like the vertex of the angle. The plural vertex is vertices, and a polygon is named naturally listing the vertices in consecutive order. Pick a point and go in one order. Your choice. It depends. Normally we go clockwise, but you can do whatever you want to do, as long as the letters go in order, concession at one point versus all the points. So, looking at these two pictures, convex versus concave, the math terms are very awesome, and I like the math terms for concave versus convex, but we're going to make it a little bit simpler for you. Convex have no vertices on the interior. So, no vertices on the interior of the polygon. Concave means vertices are on the interior, but the one that's the easiest is caves in. And convex polygons don't cave. So there's no easy quick way to get to the inside of the cave here, meaning you'd have to work around something. Caves in means there is vertices on the interior of the polygon, or you can clearly see the entrance to the cave if you wanted to think about getting to a bear or something like that. It's a quick way to remember it. Concave, caves in. So, state whether these polygons are either convex or concave. So once again, if I have caving in, then it has to cave in. Now, mind you, it could not be a polygon as well. So this is a convex polygon. This is a concave. These two are not polygons. The reason why they're not polygons is because they have a curve. You got to have a side, not a curve, a straight side with vertices. So in the top left, we do have vertices and we have some sides, but then we have these curves, and that's not a side. And then on this one, it's more like a three-point line for a basketball court. Not as curved, but or you can do the top of the key for basketball players. Is you have two vertices here, and you kind of have two sides here, but you're not clear, but there's a curve, so it's not a polygon. The next part that we have, classifying polygons, are these names that classify them out. Numbers of sides. You must know this chart. You must know triangles 3, quadrilateral is 4, not a square, not a rectangle, it's quadrilateral. Pentagon, hexagon, heptagon. Another name for 7 is septagon, which I will gladly accept. Octagon, nonagon, decagon, and dodecagon. Okay. You got to count the sides. So when you count the sides, you pick a vertex and you go either left or right, and you count how many vertices you have. That will tell you how many sides you have, because there's an equal number of vertices to sides. So on a triangle, if you start on a triangle and you count the vertices, there are 3 vertices, intersections of at least 2 sides, and that will equal the number of sides it has. Now with that, an equilateral triangle is equal lats, which is equal sides. So all sides are equal / congruent. They're equal in measure, which means they are congruent. Equal angulars is with all angles congruent. Equal measure. So a regular polygon is a convex polygon, must be convex, cannot be concave, cannot cave in on itself, is both equilateral and equal angular. I spelled equal angular wrong. Give me 1 second. Okay. So now what we have is we're going to classify the polygons based on the number of sides. Tell whether the polygon is equilateral, equiangular, regular, or none of the above. Okay, so first and foremost, to know the number of sides that you have tells you the shape. You need to know if it's convex or concaved, and then you need to tell me if it's equilateral, equiangular, or whatnot. And you can do a concave equilateral figure. So to name things. So first we're going to start off with the first one. 1, 2, 3, 4, 5. So I have 5 vertices, which means it's a pentagon. It is convex. So this is a convex pentagon. Now, it is not equilateral because all the side lengths are not congruent. We have 2 tick marks here, which means these 2 legs are congruent or sides are congruent, and these 2 sides are congruent. On your angles, these 2 angles are congruent, and then these 2 angles are congruent. Nothing is congruent above everything else. So it is not equilateral or equiangular, so then it is technically none of the above. This next one is a concave because it caves in, and we're going to count our vertices. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a decagon. So this is a concaved decagon. Now, we're not completely clear on our definition of everything for what we want to name it as and classify it as. So here we go for the next part. Looking at my angles, 1, 2, 3, 4, 5 are congruent, equilateral. Okay. Which means these angles here are equilateral, and it is equiangular, but normally we do not classify concave as equiangular. So we're going to name it based on its equilateralness. So equilateral, so this is a concave equilateral decagon. Now, it's not equiangular. 5 angles are equal, and the other 5 angles are equal, but they're not all equal to each other. Okay? This one here. So, vertices, I have 1, 2, 3, 4, 5, 6. So, this is convex. So, you have a convex hexagon. But from here, as I can see, all my sides are marked congruent, so it is equilateral. So I got equilateral, and then I have equiangular, because all my angles are congruent. So when it is equilateral and equiangular, then I need to say that it is a regular. So this is a convex regular hexagon. Okay. Turning the page. So tell whether the following statements are true sometimes or never. A square is concave. Can a square ever be concave? No, because it is equilateral and equiangular. So this would be a never true. A regular pentagon that is equilateral. A regular pentagon is always true because of the fact that it is regular, means that by definition of regular, it is equilateral and equiangular. So this is always. So draw a figure that makes or fits the description. With that, we have a convex hexagon that is not regular. So convex hexagon that is not regular. So it means it cannot be equilateral and equiangular. So I have 6 sides. It's convex, meaning nothing is caved in. And then at the same time, I do not have it being regular, meaning none of my sides are all congruent, or my angles are not all congruent. Number 2, a quadrilateral that is equilateral but not equiangular, meaning all 4 of my angles cannot be the same. With that, the square is out of the case, because a square, by definition, is 4 right angles and all congruent sides. So I can't draw a square, but I could draw what you all know as a diamond, which more is called a rhombus, but kind of looks like a kite. By these 4 tick marks, that tells me my 4 sides are congruent, even though it's not exactly. You can use a straight edge if you would like and make it prettier. So now we got some solving problems. In each diagram is a regular polygon. Find the value of x. So what we're going to do is, since these are regular, we know that this side and this side are congruent. Okay, so since these 2 sides are congruent, also the angles are congruent, I'm going to take 2x plus 15 and set it equal to 5x minus 9. And I'm going to solve this equation. Minus 2x plus 9 plus 9. 24 equals 3x. Divide by 3, x equals 8. If I want to find the lengths of the values, if I plugged 8 in, that would give me the lengths of the values of the sides. This next question, what I'm going to do is I'm going to take and set each equation together, set them equal to each other. If these were angles, I would set the angles equal together, because if it's equilateral or equiangular, you can do either one, as long as it's a word regular in front of it. So I have x cubed plus 12x minus 106 equals x cubed minus 6x minus 16. So before you all panic, I know and I see these x cubes. They're on opposite sides, so if I subtract them, they cancel out. So I get 12x minus 106 equals negative 6x minus 16. Now from here, I'm going to get the x's on the same size. So I'm going to add 106. I'm going to add 6x. 18x equals, I want to say it's going to be 90, but equals 90. Divide by 18. X equals 5. There you go.